What if everything we think we know about the pyramids is only half the story? Not the half historians are unsure about, but the half they can't quite explain. Tonight, we are going to take a very slow walk through one of the oldest mysteries in human history. And I want you to notice something as we go. Notice that the mystery is not one thing. It is not one strange fact, or one suspicious measurement, or one odd coincidence. It is a collection of details. Each one, taken alone, might be explainable, but taken together, they begin to form a pattern that is very hard to look away from. On a rocky plateau just west of the Nile River, on the edge of the Sahara Desert, 3 enormous stone mountains rise from the sand. They have been standing there for 4,500 years. They watch the armies of Alexander the Great march across Egypt. They watch the Roman Empire rise and fall. They watch the rise of Islam, the coming of Napoleon, the building of the modern world, and they are still there. Unchanged, patient, silent. To most historians, their story is settled. They were built by the pharaohs of Egypt's Fourth Dynasty, monumental tombs constructed to guide dead kings into the afterlife, extraordinary achievements of human engineering and organization. And that story is true. The evidence for it is real. But there are details inside and around these structures that don't sit quietly within that explanation. Details that archaeologists acknowledge and struggle to fully account for. Details that have driven certain researchers, geologists, astronomers, mathematicians, architects, to propose a different story. A story that is older, stranger, and in some ways, far more unsettling. Tonight, we are going to explore both. We are not here to tell you what to believe. We are here to lay the evidence gently in front of you and let it breathe. So make yourself comfortable. Let the world outside go quiet. And let's begin. To understand what is strange about the pyramids, we first have to understand the world that built them. Egypt is one of the oldest continuous civilizations in human history. For more than 3,000 years, longer than the entire span of recorded Western history, it endured. Kingdoms rose and fell and rose again. Dynasties succeeded each other for century after century, and through all of it, the Nile remained the constant. The Nile is not simply a river. In the ancient world, it was the difference between life and death. Egypt is surrounded on all sides by some of the harshest desert on earth. Without the Nile, none of it, none of the temples, none of the art, none of the civilization would have been possible. Every year, the river flooded, and every year, as the floodwaters retreated, they left behind a thick layer of dark, mineral-rich silt. The Egyptians called this land the Black Land, and in the Black Land, almost anything would grow. That agricultural abundance supported a population of millions, and that population created the surplus, the food, the labor, the time that allowed a civilization to develop, specialize, and flourish. At the peak of that civilization stood the Pharaoh. The Pharaoh was not simply a political ruler. In the theology of ancient Egypt, the Pharaoh was a divine being. He was believed to be the living embodiment of Horus, the falcon god, the god of kingship and the sky. And when he died, he was believed to transform into Osiris, the god of the dead and the afterlife. This was not metaphor. This was not poetry. The Egyptians genuinely believed their pharaoh was a god walking among them. And if the pharaoh was a god, then his tomb was not simply a burial site. It was a cosmic gateway, a machine for transformation, a structure designed to carry a divine soul from the world of the living into the eternal realm of the gods. The earliest royal tombs were relatively simple, rectangular mud brick structures called mastabas, flat-topped, low to the ground, built over underground burial chambers. But around 2650 BCE, something changed. A pharaoh named Djoser and his chief architect, a genius named Imhotep, looked at the mastaba and imagined something new. They began stacking mastabas on top of each other, each layer smaller than the one below, rising in steps toward the sky. The result was the step pyramid of Saqqara, the first large stone structure ever built by human beings, 60 meters tall, visible for miles across the flat desert landscape. It was a revolution, and it was only the beginning. Over the next century, Egyptian architects refined the concept. They experimented with angles. They learned from failures. One pyramid, the bent pyramid at Dahshur, visibly changes angle halfway up, where engineers realized the slope was too steep and corrected mid-construction. They developed new techniques for quarrying stone, transporting it, and lifting it into place. They built administrative systems capable of organizing tens of thousands of workers. And then, around 2600 BCE, a pharaoh named Khufu ascended to the throne, and everything that had come before became preparation. Khufu looked at a limestone plateau and a place called Giza, and he decided to build something the world had never seen. Something that the world, 4,500 years later, still hasn't fully explained. The Great Pyramid of Khufu is, by any measure, one of the most extraordinary physical objects ever created. Its base covers 13 acres. To put that in perspective, you could fit 10 football fields inside its footprint. It originally rose to a height of 146 meters. For nearly 4,000 years, from its completion around 2560 BCE until the construction of the Lincoln Cathedral in England in 1311, it was the tallest structure human beings had ever built. It contains an estimated 2.3 million stone blocks. Most of them weigh between 2 and 15 tons. The heaviest granite blocks deep inside the pyramid, those used to construct the king's chamber and the relieving chambers above it, weigh up to 80 tons. Those granite blocks were not quarried nearby. They came from Aswan, 800 kilometers away, up the Nile. Somehow they were cut from solid granite, a stone so hard it defeats most modern tools. Somehow they were transported down the river on wooden barges. Somehow they were dragged across the plateau. And somehow they were lifted into position inside the pyramid, dozens of meters above the ground. We do not know with certainty how any of this was done. Theories exist, and some of them are very good. Experimental archaeologists have shown that teams of workers using wooden sledges on wetted sand can move multi-ton stones surprisingly efficiently. A painting discovered in the tomb of an ancient Egyptian governor actually depicts workers pouring water in front of a sledge, evidence that this technique was real and understood. For the outer casing stones, each weighing about 2.5 tons, Most researchers believe a combination of ramps and sledges was used. But the ramp theory has a problem. A ramp long and shallow enough to move stones to the pyramid's upper levels would need to be almost as massive as the pyramid itself. You would essentially be building two enormous structures simultaneously, and there is no evidence of such a ramp in the archaeological record. In 2017, a French architect named Jean-Pierre Houdin proposed an internal spiral ramp system, a tunnel running inside the pyramid that workers used to haul stones to the upper levels. Computer modeling suggests it would work, and some anomalies detected by ground-penetrating radar inside the pyramid are consistent with such a tunnel. But it has not been confirmed. Then there is the question of time. Historians generally agree the Great Pyramid was built during Khufu's reign. His reign lasted approximately 20 years. That means 2.3 million stone blocks had to be quarried, transported, and placed in roughly 20 years. Working 365 days a year, 10 hours a day. That works out to placing one stone block every 2 minutes. Not every hour, every 2 minutes. Continuously. For 20 years. We know from archaeological evidence that the workforce numbered somewhere between 20 and 30,000 people at its peak. We know they lived in a purpose-built workers' village just south of the plateau. We know they were organized into gangs with names like Friends of Khufu and Drunkards of Menkaure, names the workers chose themselves and painted proudly on the stones. These were not slaves driven by fear. The medical evidence from skeletal remains found in the workers' cemetery shows sophisticated surgical care. Broken bones that were set and healed. Evidence of amputations that the patient survived. These were skilled workers. Valued. Cared for. The official picture is of an extraordinarily organized national project. A civilization at the absolute height of its powers, pouring everything it had into a single monument. It is a convincing picture. The evidence supports it. And yet, when you look at the pyramid's dimensions more carefully, something begins to feel different. Let's talk about what the pyramid actually is. Not what it contains. Not what it symbolizes, but what it physically is. As a structure, as a geometric object. The Great Pyramid is aligned to true north, not magnetic north, which shifts over time. True north, the actual geographic north pole of the Earth. The margin of error in that alignment is 3/60ths of a degree. Or, if you prefer, about 1/20th of a degree. That is by any standard astonishing. The Paris Meridian, a north-south line established by French scientists in the 17th century, using the best instruments available at the time, has an error of roughly 9 arc minutes. That is approximately 9 times less accurate than the Great Pyramid. We do not fully know how the Egyptians achieved this alignment. Several methods have been proposed. One of the most interesting involves observing the rising and setting positions of a single circumpolar star, a star that never dips below the horizon, and bisecting the arc it traces across the sky. This method, demonstrated in a 2000 study by physicist Kate Spence, can theoretically produce the alignment we see. But it requires extraordinary care and patience. And it requires knowing exactly what you're looking for. The precision doesn't stop at orientation. The base of the pyramid is almost perfectly level. Across its entire 13-acre footprint on a rocky limestone plateau that was not naturally flat, the difference in elevation between the highest and lowest corners is just 2 centimeters. 2 centimeters. The Egyptians somehow flattened 13 acres of bedrock to within 2 centimeters of perfect levelness, using, as far as we can tell, water channels and copper tools. The 4 sides of the base are almost identical in length. The longest is about 230.36 meters. The shortest is about 230.25 meters, a difference of 11 centimeters, across a distance of 230 meters. That is a margin of error of less than 0.05%. The corners are almost perfect right angles. The greatest deviation is about 12 arc minutes, 1/5 of a degree. And then there is the stonework itself. The outer casing stones, most of which were stripped away by later builders to construct medieval Cairo, were polished white limestone. The few that remain show a surface finish so smooth that ancient writers compared the pyramid to a mirror. And they were fitted together so precisely that the gap between adjacent stones averages about 0.5 millimeter. 0.5 millimeter. Between blocks that weigh 2 to 3 tons, cut and placed without power tools, without lasers, without modern surveying equipment of any kind. Archaeologists explain all of this as the product of accumulated Egyptian expertise, centuries of building, refining, correcting, improving. By the time Khufu built his pyramid, Egypt had been constructing large stone monuments for nearly a century. They had the knowledge. They had the workforce. They had the organizational capacity. That explanation is reasonable. But some researchers have looked at this precision and felt that it exceeds what even the most experienced builders of that era should have been capable of. That it suggests a level of theoretical knowledge, not just practical skill, that feels out of place. And that feeling deepens considerably when you start looking at the numbers. Numbers are strange things. They can be manipulated. And if you measure any large structure with enough different measurements, eventually you will find ratios and relationships that look interesting. Statisticians call this data dredging, and it is a real phenomenon. I want to acknowledge that up front, because it matters. Some of the mathematical claims made about the pyramids are almost certainly coincidental. But not all of them feel that way. Let's start with pi. Pi, the ratio of a circle's circumference to its diameter, is approximately 3.14159. It is one of the most fundamental constants in mathematics, and it appears naturally whenever you encounter circles, cycles, waves, or curves. The earliest known written approximation of pi in history comes from the Rhind mathematical papyrus, an Egyptian document dating to around 1650 BCE, nearly 1,000 years after the Great Pyramid was built. The Egyptians at that time approximated pi as roughly 3.16, close, but not precise. Now consider the Great Pyramid. If you take the height of the pyramid and divide it into twice the length of one base side, you get a number very close to pi. Not 3.16, closer to 3.14159, accurate to several decimal places. There are two ways to interpret this. The first is that it's a coincidence. The pyramid's slope was determined by a practical surveying ratio. The Egyptians used a unit called the secant to maintain consistent angles, and pi simply falls out of that ratio by accident. The second interpretation is that the ratio was intentional, that the architects knew pi, worked with it, and encoded it deliberately into the pyramid's proportions. We cannot prove either interpretation, but the number is there, regardless of how it arrived. Then there is the golden ratio. The golden ratio, approximately 1.618, is a proportion that appears throughout nature. In the spiral of a nautilus shell, in the branching of trees, in the proportions of the human body. Ancient Greek mathematicians found it fascinating. Renaissance artists built it into their work deliberately. When you examine the cross-section of the Great Pyramid, a triangle formed by the height, the base, and the slope face, the dimensions produce a golden ratio relationship. The ratio of the slant height to half the base is approximately 1.618. Again, coincidence or intention? The answer depends on what you believe the Egyptians knew. But the most striking mathematical relationship involves something much larger than the pyramid itself. It involves the Earth. In the 19th century, a Scottish astronomer named Charles Piazzi Smith began making extremely careful measurements of the Great Pyramid. He was one of the first people to observe that the pyramid's dimensions appeared to relate to the dimensions of the Earth. His conclusions were controversial, and many of his specific claims were overstated. But the core observation has persisted. Here is the relationship as it stands today. The Earth is not a perfect sphere. It bulges slightly at the equator due to its rotation. The distance from the center of the Earth to the equator, the equatorial radius, is approximately 6,378 kilometers. The distance from the center of the Earth to the poles, the polar radius, is approximately 6,357 kilometers. Now take the height of the Great Pyramid, 146.5 meters. Multiply it by 43,200. You get approximately 6,326 kilometers, which is within 1% of the polar radius of the Earth. Take the base perimeter of the pyramid, approximately 921.5 meters. Multiply it by 43,200. You get approximately 39,800 kilometers. The actual circumference of the Earth at the equator is 40,075 kilometers, a discrepancy of less than 1%. Critics ask, why 43,200? Why that particular multiplier? Because 43,200 is not arbitrary. It is derived from one of the most fundamental astronomical cycles known, the precession of the equinoxes. The Earth's axis wobbles very slowly, like a spinning top that is gradually losing energy. It traces a great circle in the sky over a period of approximately 25,920 years. 25,920 divided by 60 is 432. 43,200 is exactly 432 multiplied by 100. The number 43,200 is a direct mathematical echo of the Earth's precessional cycle. And somehow, it is also the exact scale factor that connects the pyramid's dimensions to the size of the planet. To explain that, as coincidence requires a very specific kind of faith. The faith that an enormous number of accurate relationships can stack on top of each other by chance. For some researchers, that faith is harder and harder to maintain. Let's go inside. The entrance to the Great Pyramid is on the north face, about 17 meters above ground level. From there, a narrow descending passage, just over a meter wide and barely tall enough to stand in, cuts down through the body of the pyramid at a steep angle. It descends for about 28 meters before leveling out, then continues down into the bedrock below. At the bottom of this descending passage, there is an unfinished chamber, rough and empty. Its purpose is still debated. But partway down the descending passage, something unusual happens. There is a junction. A second passage branches upward, an ascending passage, cutting back up through the stone at almost exactly the angle the descending passage cuts down. This ascending passage was originally sealed with 3 massive granite plugs. When the pyramid was first entered by Arab workers under Caliph al-Ma'mun around 820 CE, they had to tunnel around these plugs to get through. The ascending passage leads upward for about 40 meters before opening into something extraordinary. The Grand Gallery. The Grand Gallery is a corbelled passageway, meaning its walls rise in overlapping layers, each layer projecting slightly inward, forming a tall, narrow vault. It is 8.7 meters tall, 47 meters long, and it rises at the same steep angle as the ascending passage, roughly 26 degrees. Standing in the Grand Gallery And looking up is one of the most unusual experiences a person can have inside any ancient structure. The proportions are strange. The space feels both vast and narrow at the same time. The corbelled ceiling stretches away above you into shadow. Along the ramp floor of the Grand Gallery, there are a series of rectangular slots cut into the side benches. 27 of them, evenly spaced. Their purpose is unknown. At the top of the Grand Gallery, you reach a low granite passageway, the antechamber. Originally sealed by 4 massive granite portcullis slabs that could be lowered from grooves in the walls. All of them now broken or removed. Beyond the antechamber is the King's Chamber. The King's Chamber is a room of red Aswan granite, 5 meters wide, 10 meters long, 5.5 meters tall. Every surface, floor, walls, ceiling, is lined with perfectly fitted granite blocks. At the western end of the room sits a lidless granite coffer, slightly larger than the entrance to the ascending passage, meaning it had to be placed in the chamber before the pyramid was finished. Its dimensions correspond almost exactly to those described by Egyptologist Flinders Petrie as consistent with a standard ancient Egyptian unit of volume. But there is no lid, no inscription, no evidence of a mummy, no trace of any burial goods. This coffer has never, in recorded history, been found to contain human remains. Above the King's Chamber are 5 spaces known as the relieving chambers, stacked above each other like a sandwich. The uppermost one has a pointed roof. Together they distribute the enormous weight of the stone above away from the chamber ceiling. An elegant engineering solution. It was inside these relieving chambers that workers' inscriptions were found, the only hieroglyphic writing in the entire pyramid. Gang names, including one that reads phonetically, "The gang, how powerful is the white crown of Khufu." This inscription is one of the primary pieces of evidence linking the Great Pyramid to Khufu. It is accepted as genuine by the vast majority of Egyptologists. But it sits in a hidden room above the main chamber, not in the burial chamber itself, not anywhere a living person would normally see it. The pyramid, from the inside, is almost entirely silent. And that silence, in a culture that wrote on virtually every available surface, remains one of its deepest puzzles. There is something else inside the Great Pyramid that is rarely discussed in popular accounts. Something that has generated significant debate among astronomers and archaeologists. Running from both the King's Chamber and the Queen's Chamber are 4 narrow shafts, 2 from each chamber, one pointing north, one pointing south from each. They are roughly 20 centimeters square, and they run through the body of the pyramid at precise angles. These are often called air shafts, but that name is misleading. The shafts from the Queen's Chamber don't reach the exterior of the pyramid. they stop short, sealed behind a small stone door, a door discovered only in 1993 when a robot camera was sent up the shaft. Whatever these shafts were for, they were not simply for ventilation. In the early 1990s, Belgian civil engineer Robert Bouval made a careful study of the shaft's angles. He calculated where each shaft would have pointed in 2500 BCE, accounting for the slow shift of stars caused by the precession of the equinoxes. What he found was striking. The southern shaft from the king's chamber points toward Orion's belt, specifically the star Al-Nitak. Al-Nitak was associated in Egyptian astronomy with Osiris, god of the afterlife. The northern shaft from the king's chamber points toward Thuban. In 2500 BCE, Thuban was the pole star, the star that sat almost exactly at the celestial North Pole, the still point around which all other stars appeared to revolve. The southern shaft from the Queen's chamber points toward the star Sirius. Sirius was the most sacred star in Egyptian religion, associated with Isis, the goddess of magic and resurrection. And its annual rising, its first appearance above the horizon at dawn, marked the beginning of the Egyptian New Year and predicted the Nile flood. The northern shaft from the Queen's chamber points toward a star in Ursa Minor. The pattern is not random. If these alignments were intentional, and the angular precision required to achieve them strongly suggests they were, then the architects built astronomical sightlines directly into the body of the pyramid. Narrow stone tubes, embedded in millions of tons of masonry, pointing with precision at specific stars in the sky. The king's soul would travel the southern shaft toward Orion, toward Osiris. It would travel the northern shaft towards the imperishable stars, the circumpolar stars that never set, never die. Or perhaps the shafts were not for travel at all. Perhaps they were for something else entirely. A way of drawing starlight into the heart of the pyramid. A connection between the stone and the sky. What lies beyond the door at the end of the Queen's chamber shaft is still unknown. In 2002 and again in 2011, robot cameras were sent through the shaft to examine it. The second robot drilled through the first door and found a short chamber and a second door. Behind that second door, the camera could not see. What is in that space has not yet been determined. Whatever it is, it has been there for 4,500 years, waiting in the dark for someone to look. Stand at the edge of the Giza plateau and look east. In front of the pyramid complex, carved directly from the living limestone bedrock of the plateau, is a figure that has been watching the eastern horizon since before recorded history. The Great Sphinx. It has the body of a lion, 73 meters long, 20 meters tall, and a human head, the face of a pharaoh, though which pharaoh is a matter of considerable debate. It is the largest monolithic statue on Earth, carved not from assembled blocks, but from a single continuous mass of stone. The quarry that provided stone for the nearby pyramid complex left behind a natural hill of limestone, and from that hill the Sphinx was shaped. Most Egyptologists believe the Sphinx was carved during the reign of Pharaoh Khafra, around 2500 BCE. The face is said to resemble statues of Khafra found nearby, and a stele placed between the Sphinx's paws by a later pharaoh, Thutmose IV, appears to associate the Sphinx with Khafra's pyramid complex. This is the mainstream view. It is reasonable. It fits within the broader archaeological timeline. But in 1991, a geologist from Boston University named Robert Schoch visited the Sphinx and began examining something that Egyptologists had largely overlooked: the erosion. The Sphinx and the walls of the enclosure surrounding it show a very particular pattern of weathering. The erosion is deep. It is rounded, and it runs in undulating vertical channels down the walls. Schoch recognized this pattern. He had seen it before on other limestone formations that had been exposed to prolonged heavy rainfall over long periods of time. Wind erosion and sand erosion produce horizontal scarring. They cut laterally. They abrade surfaces uniformly. What Schoch was looking at was different. The vertical rounding was consistent with water running down the face of the stone. Rainwater. Lots of it. Over a very long time. Here is the problem with that observation. Egypt has been essentially rainless for approximately 5,000 to 7,000 years. The Sahara Desert, which had been a relatively green savanna during the early Holocene, the period following the last ice age, became progressively more arid from around 5,500 BCE onward. By 3000 BCE, the climate was much as it is today. For the Sphinx to show heavy water erosion, it would have had to be carved and exposed to the elements during a significantly wetter climatic period. That period ended thousands of years before Khafra was born. Schoch's conclusion, presented to the Geological Society of America in 1991, was that the Sphinx body is significantly older than Egyptologists believe, possibly dating to between 7,000 and 5,000 BCE, or even earlier. The reaction from Egyptology was swift and largely dismissive. If the Sphinx dates to 7,000 BCE, that would place its construction in a period when there is no archaeological evidence of a civilization in Egypt capable of building anything remotely comparable. The counter-argument was that the erosion could be explained by chemical weathering, salt from the desert air reacting with the limestone, or by periodic flooding from the Nile. Schoch has spent the last 3 decades responding to these objections. He has pointed out that salt weathering produces very different erosion patterns, that Nile flooding does not reach the plateau, that the walls of the enclosure, which are cut from the same limestone and at the same depth, show exactly the same weathering as the Sphinx body, while other structures on the plateau built during Khafra's time do not. The debate remains unresolved, which is worth sitting with, because an unresolved debate between a credentialed geologist and the mainstream archaeological consensus is not the same as a fringe theory. It is a genuine scientific disagreement. And if Schoch is right, even partially right, then the Sphinx was watching the sunrise long before Egypt became Egypt, long before the Pharaohs, long before writing, long before any civilization we know of was capable of carving it. On a clear night above the Giza plateau, the sky is extraordinary. Without the light pollution of modern Cairo to the east, the stars come out in their thousands. The Milky Way stretches overhead, a pale river of light crossing the sky from horizon to horizon. And there, in the winter sky, is Orion. Orion is one of the most recognizable constellations in the night sky. Its most distinctive feature is a line of 3 stars in close proximity, the belt. The stars have Arabic names: Al-Nitak, Al-Nilam, and Mintaka. They form a nearly straight diagonal line, tilted slightly to the southwest. To the ancient Egyptians, Orion was Sahu, the celestial embodiment of Osiris, god of the dead, god of resurrection, ruler of the Duat, the underworld realm where the souls of the dead were judged and transformed. The pyramid texts, the oldest religious writings in the world, carved inside the pyramids of later pharaohs from around 2400 BCE onward, describe the king's soul rising to join Orion in the sky. Behold, he has come as Orion. Orion is the soul of Osiris. You shall go up and down with Orion. The connection between the pyramid and Orion was clearly embedded in Egyptian theology. What Robert Bauval proposed in his 1994 book, The Orion Mystery, was that it was also embedded in the landscape. Look at the 3 pyramids at Giza from above. The 2 largest, Khufu's and Khafra's, are almost perfectly aligned diagonally. The 3rd, Menkaura's, the smallest, is offset to the east. Now look at Orion's belt. Al-Nitak and Al-Nilam form a nearly diagonal line. Mintaka, the westernmost and faintest of the 3 belt stars, is offset slightly to the north. The match is not perfect. The actual positions of the stars relative to each other do not align precisely with the pyramid layout when you overlay them. The pyramids are displaced to the west relative to where a perfect match would place them. Bauval's explanation for this is the Milky Way. He proposed that the Nile, the great river that was the lifeblood of Egypt, was intended to represent the Milky Way. That Giza was positioned relative to the Nile in the same way that Orion is positioned relative to the Milky Way in the sky. The entire Giza plateau, in this interpretation, is a mirror of the heavens, a map of the sky, written in stone and sand. Critics have pushed back on several aspects of Bauval's theory. The match between the pyramids and Orion's belt, they argue, is approximate at best, and there are many ways to match patterns from the sky to patterns on the ground if you are willing to be flexible enough. But Beauval added another layer to his argument, one that is harder to dismiss. Because of the precession of the equinoxes, the slow wobble of Earth's axis, the position of stars relative to the horizon changes over long periods of time. Stars that were high in the sky thousands of years ago are now lower. Stars that were below the horizon have risen. Beauval ran the astronomical clock backward, and he found that the alignment between the Giza pyramids and Orion's belt reaches its closest match, the point at which Orion sits lowest in the sky, in its precessional nadir, around 10,500 BCE. 10,500 BCE. 12,500 years ago, at the end of the last ice age. This date appears in multiple contexts around the Giza plateau. It is the date to which the Sphinx faces when you consider its astronomical orientation, and it is the beginning of a hypothesis that once you encounter it, is very difficult to let go of. For most of the 20th century, there was a comfortable assumption underlying the story of human civilization. The assumption was this: before agriculture, humans were simple. Before settled cities, humans were nomadic and unsophisticated. Complex architecture, symbolic thought, and organized religion were products of civilization. They came after the development of farming, after the building of towns, after writing. This assumption seemed reasonable. It fit the archaeological record as it was understood, and it placed the earliest evidence of complex human activity at around 5,000 to 6,000 BCE in Mesopotamia, in the Fertile Crescent between the Tigris and Euphrates rivers. Then, in 1994, a German archaeologist named Klaus Schmidt arrived at a site in southeastern Turkey, near a town called Şanlıurfa, on a limestone ridge in the Taurus Mountains. Local farmers had been finding worked flint in the area for decades. Archaeologists had visited briefly in the 1960s and dismissed the site as a medieval cemetery. Schmidt had a different instinct. He began to dig. What he found over the next 20 years of excavation would permanently alter our understanding of human prehistory. Buried beneath the hilltop was a complex of enormous stone circles. Each circle made up of T-shaped limestone pillars, some of them 6 meters tall, some weighing more than 20 tons. The pillars were not rough. They were precisely shaped, and they were carved with animals, with abstract symbols, with scenes of predatory creatures, foxes, scorpions, vultures, lions, depicted with skill and intention. When Schmidt dated the site, the result was almost impossible to process. Göbekli Tepe, the name means Potbelly Hill in Turkish, was approximately 11,500 to 12,000 years old, dating to around 9,500 to 10,000 BCE. nearly 7,000 years older than the pyramids, older than the invention of writing, older than the wheel, older than pottery, older than agriculture. The people who built Göbekli Tepe were, according to standard archaeological classification, hunter-gatherers. They had no cities, no farming, no bronze tools. And yet they organized a workforce capable of quarrying and transporting 20-ton limestone pillars. They carved those pillars with sophisticated symbolic imagery. And they built a complex that shows evidence of deliberate astronomical alignment. To feed the workers who built this site, and building it would have taken generations, somebody had to organize food production on a large scale. Some archaeologists now believe that it was the construction of Göbekli Tepe itself that drove the development of agriculture in the region. That the temple came first, and the farming grew around it. That is the opposite of everything we assumed. And it means that the capacity for complex organized construction, symbolic thought, and large-scale social cooperation is far older than anyone imagined. Perhaps most significantly, Göbekli Tepe was deliberately buried. Around 8000 BCE, someone, the same culture, or their descendants, filled the entire complex with rubble and soil, deliberately concealing it. Why is unknown. And crucially, only about 5% of the site has been excavated. Ground-penetrating radar suggests that there are many more circles still buried in the hill. Göbekli Tepe proved something important. It proved that our picture of early human capability is incomplete, that there are chapters in the human story that we have not yet found. If hunter-gatherers 12,000 years ago could build Göbekli Tepe, what else might have existed? What else might have been built? And where is it now? Around 12,000 years ago, the Earth was a very different place. The last ice age was at its peak roughly 20,000 years ago. At that time, enormous ice sheets covered much of North America and Europe. Sea levels were dramatically lower than they are today. By some estimates, roughly 100 to 20 meters lower. That difference is almost impossible to fully visualize. But consider what it means in practice. At sea levels 120 meters lower than today, vast areas of what is now shallow ocean floor were dry land. The North Sea did not exist. Britain was connected to continental Europe. The Persian Gulf was a fertile river valley. The Sunda Shelf, an area of shallow ocean between the islands of Southeast Asia, was a landmass roughly the size of India. Coastlines around the world were completely different. And those coastlines, the sheltered, temperate zones where fresh water meets the sea, are precisely the environments where early human civilizations tend to develop. Beginning around 14,000 years ago, the ice began to melt. Not gradually, not smoothly, in pulses, dramatic, sometimes catastrophic pulses of meltwater. One of the most significant of these events is known as meltwater, Pulse 1a. Around 14,000 years ago, global sea levels rose by approximately 20 meters in roughly 500 years. That is a rise of about 4 centimeters per year, which sounds modest until you consider it applied to every coastline on Earth simultaneously. There were subsequent pulses. And then, around 11,600 years ago, right at the beginning of our current geological epoch, the Holocene, there is evidence of an extraordinary event. Ice cores, ocean sediment cores, and geological records from around the world show a dramatic and sudden climatic transition. Temperatures shifted. The remaining ice sheets destabilized, and sea levels jumped. The low-lying coastal lands that had been dry for 20,000 years were inundated. Rivers became estuaries. Hills became islands. Valleys became bays. Everything that had been built there, every structure, every settlement, every trace of habitation, went underwater. And here is the thing about underwater archaeology. It is extraordinarily difficult. The submerged continental shelves of the world have been barely explored. We have better maps of the surface of Mars than we do of the ocean floor. What lies beneath the shallow seas around India, around Southeast Asia, around the Persian Gulf, around the Mediterranean? We genuinely don't know. We do know of a handful of submerged sites. Dwarka, off the coast of India, where stonework structures have been found at depths of up to 40 meters. Yonaguni, off Japan, where a stepped stone formation has been the subject of debate for decades. Natural formation or constructed monument, the argument is genuinely unresolved. A stone circle found off the coast of northern Israel. Sunken forests and submerged landscapes in the North Sea. None of these individually prove the existence of a lost advanced civilization, but they demonstrate that there is a vast amount of prehistoric territory beneath the sea. Territory that was inhabited by humans. Territory that has barely been looked at. Every flood myth in every culture tells a story of a world that was lost. The Sumerian flood narrative, the book of Genesis, the Greek story of Deucalion, the Hindu account of Manu, the indigenous flood traditions of the Americas. Flood myths appear on every inhabited continent, in cultures that had no contact with each other. Historians typically explain this as a natural human response to the experience of local flooding. Floods are common and dangerous. Mythologizing them makes psychological sense. But some researchers have wondered whether these stories share a common origin. Whether they are all, in some deep and distorted way, memories of the same event. The end of the Ice Age. The rising of the seas. The drowning of a world. We have now assembled a number of separate pieces. A pyramid of impossible precision. Mathematical relationships that appear to encode knowledge of planetary geometry. A sphinx that may predate the civilization credited with carving it. astronomical alignments built into the layout of the plateau. A 12,000-year-old megalithic temple that rewrote the story of prehistoric human capability, and a world-altering climate catastrophe that drowned vast areas of potentially inhabited coastline. One hypothesis, developed most extensively by author and journalist Graham Hancock, but drawing on the work of geologists, astronomers, and archaeologists, attempts to connect these pieces. The hypothesis goes like this. During the last ice age, a sophisticated civilization existed. We don't know where. We don't know exactly what it looked like. But it had developed, over a very long period of time, deep knowledge of astronomy, mathematics, architecture, and navigation. When the Ice Age ended and sea levels rose, this civilization was largely destroyed. Its coastal settlements, which is where most complex civilizations develop, went underwater. Its records, its monuments, its cities, gone. But not all of its knowledge was lost. Survivors, refugees of a drowned world, carried fragments of that knowledge with them. They became the mythological civilizer figures found in so many ancient cultures. The bringers of agriculture, astronomy, law, and architecture. In Mesopotamia, there is the figure of Oannes, a being described as half fish, half man, who emerged from the sea and taught humanity writing, science, and civilization. In Egypt, there is the concept of Zep Tepi, the first time, a primordial golden age that preceded the historical pharaohs. In the Americas, there are the Viracochas, the Quetzalcoatls, the great bearded strangers who appeared from across the sea and brought knowledge. Hancock's argument is not that aliens built the pyramids, or that there was magic involved. His argument is that the ancient Egyptians may have inherited astronomical and geometrical knowledge from an earlier culture, a culture we have not yet found, a culture that understood the size of the earth, the precession of the equinoxes, and the mathematics of planetary geometry, and that when they built the pyramids for their own religious and funerary purposes, using their own labor and their own techniques, they used that inherited knowledge as their foundation. This is not accepted by mainstream archaeology. The consensus is clear. There is no confirmed evidence for a technologically sophisticated civilization before the known historical record. The pyramids can be explained without recourse to a lost predecessor culture. The anomalies, however intriguing, do not require that explanation. And that is a fair and honest statement of the evidence as it currently stands. But the evidence as it currently stands is also incomplete. Göbekli Tepe was unknown to us 40 years ago. The extent of Ice Age sea level change has only been fully mapped in recent decades. The shallow continental shelves remain largely unexplored. The absence of a confirmed lost civilization is not proof that no such civilization existed. It may simply be proof that we haven't looked in the right places yet, or that those places are currently underwater. Before we close, there is one more thing worth considering. pyramid is not an Egyptian invention. Or rather, it may not be. Because pyramid-shaped monuments appear independently in cultures across the world. Cultures that had no known contact with each other. Cultures separated by oceans. And yet, each of them, in their own time and place, looked up and decided to build toward the sky in the same fundamental shape. In Mexico, the ancient city of Teotihuacan, built by a civilization whose name and language we don't know, contains the Pyramid of the Sun. It is roughly the same base perimeter as the Great Pyramid of Giza. Its orientation encodes astronomical relationships, and its name, given by the later Aztecs who found it already ancient and abandoned, simply means the place where men become gods. The Maya built pyramids throughout Central America. At Chichen Itza, the pyramid known as El Castillo is a precision solar calendar. On the spring and autumn equinoxes, the setting sun casts a shadow that creates the illusion of a serpent descending the staircase. A celestial clock encoded in stone. In Sudan, the ancient Nubian civilization of Meroe built over 200 pyramids, more than Egypt itself, steeper than their Egyptian counterparts, smaller, but unmistakably part of the same tradition of sky-pointing stone. In China, dozens of large earthen mounds near the ancient capital of Xi'an are believed to be the tombs of Han Dynasty emperors. Some researchers have described them as Chinese pyramids. The Chinese government has been historically reluctant to allow excavation. On the Indonesian island of Java, a site called Gunung Padang, which means Mountain of Enlightenment, has been the subject of intensely controversial research. Ground-penetrating radar and drill core samples suggest that beneath the visible stone terraces, there may be constructed chambers buried under many meters of soil. One team of Indonesian geologists published a paper in 2023 claiming the site could date to as far back as 25,000 years. The mainstream archaeological response was deeply skeptical. The debate is ongoing. Why do pyramids appear across the world? The conventional explanation is convergent development. The pyramid shape is structurally stable. A wide base supporting a narrowing peak distributes weight efficiently. Any culture building large monuments in stone will naturally converge on this shape because physics demands it. That is a reasonable explanation. But it doesn't fully account for the astronomical alignment or the mathematical sophistication or the consistent symbolic connection between the pyramid shape and the sky, the stars, and the afterlife. Across Egypt, Mexico, Cambodia, India, and Indonesia, cultures that built pyramids consistently oriented them to celestial events, solstices, equinoxes, rising stars, the cardinal directions. It is as if the pyramid was not just a shape, but an idea about the relationship between earth and sky, between the human and the divine, between the mortal body and the eternal soul. Where that idea came from Whether it arose independently in each culture, or whether it has a single, deeper origin that we haven't yet found, is one of the great open questions of human prehistory. The study of the pyramids is not finished. Even now, with 4,500 years of human attention focused on these structures, new things are still being found. In 2017, an international research team called Scan Pyramids used muon tomography, a technique borrowed from particle physics, to look inside the Great Pyramid without drilling a single hole. Muons are subatomic particles produced when cosmic rays hit the upper atmosphere. They pass through solid stone, the way X-rays pass through flesh. By placing detectors inside the pyramid and tracking how muons were absorbed, the team could map the density of the stone above them. What they found in 2017 was a large void, located above the Grand Gallery, at least 30 meters long, possibly much longer, with a shape and orientation different from the relieving chambers already known. A hidden space inside the Great Pyramid that had gone undetected for 4,500 years. The team named it the Big Void. Its function is completely unknown. In 2023, the same team announced further refinements to their data. The Big Void appears to be a corridor-shaped space, approximately 9 meters wide and 2 meters tall, running along the north face of the pyramid, above the main entrance, possibly functioning as a stress-relieving feature above the entrance passage, or possibly something else entirely. We do not know, because we have not been inside it, and accessing it without damaging one of the world's most important monuments is an engineering challenge that has not yet been solved. Meanwhile, ground-penetrating radar surveys of the Sphinx enclosure have continued. Various anomalies have been detected beneath the plateau. Possible tunnels, possible chambers. The Egyptian government has placed strict limits on excavation in the area. Whether this is out of caution or for other reasons depends on who you ask. Ancient Egyptian texts themselves speak of hidden chambers beneath the plateau. The Hall of Records, a legendary library containing the accumulated knowledge of a civilization before the flood, has been described in Hermetic texts and by Edgar Cayce, the American mystic who claimed in the 1930s that it lay hidden beneath the left paw of the Sphinx. No such chamber has been confirmed. But anomalies detected by ground-penetrating radar in that exact location have been noted by multiple research teams. The evidence is inconclusive. The interpretations are contested. The access is restricted. And the plateau holds its silence. It is late now. The questions we've been sitting with tonight are old questions. Some of them are as old as human curiosity itself. People have been standing before the pyramids and asking why for as long as the pyramids have existed. Ancient Greeks who visited and couldn't believe what they were seeing. Arab scholars of the medieval period who wrote treatises on what the pyramids might contain. Napoleon's soldiers who stood before them in 1798 and reportedly fell silent, and the millions of people who have stood on that plateau in the modern era and felt something they couldn't quite name. The feeling that these structures are more than they seem. The feeling that something important is being communicated. The feeling that time itself is different here. On one side of the story, we have archaeology. Evidence painstakingly assembled from quarries and workers' villages, from radiocarbon dates and inscriptions, from tools and ramps and medical waste. This evidence tells us that the pyramids were built by extraordinary human beings, working with extraordinary skill and determination, for extraordinary reasons rooted in their belief about the soul and the cosmos. That story requires no mystery to be magnificent. On the other side, there are the details that don't settle. The precision that exceeds what we expect. The mathematics that encode knowledge not supposed to exist. The weathered face of a lion older than its civilization. The star shafts aimed at Osiris and the imperishable stars. The dateless plateau that Robert Bovell's astronomy points back to the end of the last ice age. And Göbekli Tepe, always Göbekli Tepe, reminding us that the human story goes further back and deeper than we have yet been willing to imagine. Perhaps both things are true at once. Perhaps the ancient Egyptians built the pyramids exactly as archaeology describes. With their hands, their ropes, their sledges, their extraordinary organizational genius. And perhaps they did so using knowledge that came from somewhere older. Knowledge that was given to them, or inherited by them, or found by them in texts or traditions stretching back to a world now lost beneath the sea. These possibilities are not mutually exclusive. What is certain is this: the Great Pyramid was built with care, with precision that bordered on obsession, with mathematical relationships encoded into every dimension, by people who understood the sky, who understood the earth, and who wanted, desperately wanted, to create something that would last. And they succeeded. 4,500 years. 2.3 million stones. A silence that has outlasted every empire, every language, every civilization that has risen in its shadow. It is still there. Tonight, while you sleep, it is still there. On the edge of the desert. Watching the stars turn overhead, the way it has every night for 45 centuries. Keeping its secrets. Patient as stone. Waiting for someone to finally understand. So let the questions go now. Let them drift out into the dark, into the desert wind. The pyramids have been waiting 4,500 years. They can wait until morning. Sleep.